I stopped making this video to go over part D of the Tidewater Landing Stadium project. For this part, we're going to be taking the profit function that we made in part C. Right? Everyone should have their own profit function. And we're actually going to be analyzing that to figure out what are the ticket prices that Rhode Island FC should charge for their stadiums. Right? We're going to talk about what ticket prices are going to lead them to positive profit and what is the best ticket price for them to charge. Right, they want to earn more money than they're spending, so we're looking for positive profit, and we're going to be looking for what is the best solution for them, right? What is the best ticket price to charge? So as always, to approach this, we're going to be going through the math for the Oliver concert problem. Just as a reminder, Oliver is planning a concert, confident that if he sells tickets for $5, 300 people will come. Every $1 increases the ticket price, 6 fewer people will. And the cost is 4,200. We use that in part A to create a demand equation. And then in part C, we use that to make a profit equation. And so what does this equation tell us? This equation tells us the profit that Oliver can earn by selling tickets for X dollars, right? That's important. This profit does not just represent the profit, but it's the profit that he can earn by selling tickets for X dollars, right? It's important. It's a function of X. So we're going to think about, what do the zeros of this function represent? What does it mean when Y is equal to 0? Well, if Y is our profit and Y is equal to 0 and it's a function of X, well then the zeros represent the ticket prices for which, okay, the ticket prices for which Oliver will earn $0. And so if we're looking for the zeros, we're looking for the ticket prices where Oliver will earn $0. But we want to set Y equal to 0, and we're going to get 0 is equal to negative 6x squared plus 330x minus 4,200. Right? This is our profit function. This is our profit function. We're setting it equal to 0, right? Because Y is equal to 0. To figure out what are the ticket prices that lead to a profit of $0. And we know when we have an equation like this, we can solve it using the quadratic formula. So we want to identify A is equal to negative 6, B is equal to 330, C is equal to negative 4,200. Remember our quadratic formula, that's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This means x is equal to negative 330 plus or minus the square root of 330 squared minus 4 times negative 6 times negative 4,200 all over 2 times negative 6. So now we're going to want to simplify 1, 2, 3, 4 things all at once. There's nothing we can do with the negative 330, so we're going to leave that. Plus or minus the square root of 330 squared. Give me 1 second to pull out my calculator. We have 330 squared. Can give us 108,900 minus, and we're going to want to do negative 4 times negative 6 times negative 4,200. That's going to give us 1,800. All of that over negative 12. Now we can simplify what's in here. We're going to get x is equal to negative 330 plus or minus the square root of 1,000 or 108,900 minus 100,800 is going to give us 8,100. Don't know why I made that radical so big. All over negative 12. And if you put in your calculator the square root of the square root of 8,100, you're going to get 90. So we know that's equal to 330 plus or minus 90 all over 12. If we break that up, we have x is equal to negative 330 plus 90 over negative 12, and x is equal to negative 330 minus 90 all over negative 12. 330, so negative 330 plus 90, that gives us negative 240 over negative 12, and give us a ticket price of $20, right? X is equal to 20. This is going to be $420. You're going to be negative 420, right? Negative 330 minus 90 over negative 12, which is going to give us 35. So we found our two x values. X is equal to 20 and 35. And let's take a step back and think about what do these actually mean in the context of the problem. So we have this profit function that says the amount of profit that Oliver can earn for selling tickets for X dollars. So whatever the value of X is, Y tells us the amount of profit that we can get. We said what happens when Y is 0, and we solve for the X values. And therefore, if these are the X values, those are the ticket prices for which Oliver would earn ticket prices for which Oliver would earn $0 in profit, right? So now we're going to verify that using Desmos. So we're going to jump over to Desmos, and I already typed in our equation. And if you'll notice, we don't see anything. The reason why we don't see anything is because our window is only showing from negative 10 to 10 for X and from negative 10 to 10 for Y. But that's not enough, right? If we look at our function, we have some big numbers in it. So we're going to want to change that values, change the window that we're seeing. And to do that, at the top, you can go graph settings, and I recommend you change it from negative to be from negative 10, right? Changing these values here up to 80. And then for Y, we're going to change them from negative 250 up to 750. And now our graph looks like this, right? We see that we have a quadratic function, right? We see, and furthermore, if we look at our zeros, we see that, yep, our profit Y is in fact 0 when X is equal to 20 or when X is equal to 35, right? So that makes sense that those two are there. If we want to look at, right, so now if we go back, what we can see is that as long as the ticket price is between X is equal to 20 and X is equal to 35, right, as long as the ticket price is anywhere between those two, then the amount of profit that we're earning, right, the amount of profit, that's positive, right? If we're below 20, then profit is negative. If we're above 35, the profit is negative. And so when we're between 20 and 35, that's where profit is positive. So if we jump back over here, what are all of the ticket prices that Oliver can expect to earn positive profit? All ticket prices between $20 and $35. And now our last question is, what ticket price should Oliver charge if he wants to maximize the amount of money that he makes from this event? How much profit will he earn? And so for that, if we want to see the maximum, right, we're looking at, so y, how far up this graph goes, represents the amount of profit, and x is the ticket price. So where will he earn the most profit? Well, that's in the middle. That's at the vertex. That's the point 27.50, 337.50. And so if Oliver wants to earn as much profit as possible, he'll do he'll charge $27.50. That's your X value. And he will earn 337.50 in profit. So for that one, we're taking the vertex of the quadratic when we graph it, and he should charge 27.50 to earn 337.50 in profit. All right, so we jump back to the Tidewater Landing Stadium project. This is the exact process you're going to want to do. So you're going to want to take your profit function and you're going to use the quadratic formula to find the zeros, right? For find the ticket prices that based on your profit function, Tidewater Landing Stadium would earn 0 profit. And then you're going to check that using Desmos. And you're going to say, what are all of the ticket prices that Rhode Island FC will earn positive profit? Then you're going to look for the vertex. Again, using the graph, you're going to look for the vertex. And you're going to say, what is the X value? What is the ticket price of that vertex? And then your Y value, what is the profit that they will earn with that if they charge that ticket price? So this is what you want to be filling out for part D. That's our goal. One thing that might happen, it may or may not occur to you, but may or may not occur for you. But let's say that you created your profit function and it ended up looking something like not that, this, right? You have a profit function that looks like this. Where are the zeros of this profit function? Well, this up here is where y is equal to 0, but your graph is way down here. So we look at the highest point that this reaches, it's at negative $662, right? So profit never reaches a positive number, it is always negative. When you do your quadratic formula, you're not going to get a real solution, right? This equation never hits, it's never positive, right? Profit is never 0, profit is always negative. So when you try and solve for when it's going to be negative, you're not going to get a real solution. You're going to get a solution involving an I, right? You're going to get an imaginary solution. That is okay, right? I want you to show that work, show the equation, show the answers that you get that are imaginary, and then when you do your analysis of it, you're going, when it asks what ticket prices will they earn positive profit, you're going to say there are no ticket prices that you're going to use positive profit. You're still going to graph it, and your profit maximizing ticket price is still going to be the vertex, and you're going to write down the negative profit. So that may not happen for all of you, but it will probably happen for some of you, where your vertex is negative. That's okay. All right, and after you've done that, you are done with part D of the Tidewater Landing Stadium project.